Today we are going to talk about bodies. Yes, bodies. And it's going to be very interesting, at least I hope, of course. But please do not think of human bodies or bodybuilding, body art, body language, or whatever, since this podcast, as you know, is not about anatomy, fashion, or art. Maybe in one of the next episodes we could address some of this stuff because I'm sure you would enjoy it, but at the moment it's better to keep on our journey along the ceramic production lines. And so, the bodies we are going to talk about are, of course, the ceramic bodies, also called ceramic mixtures. As you know, ceramic mixtures without chemicals can be a real and serious mess, but don't start worrying already because we are here for this. In fact, joking aside, we will try to make a list of the most important categories of chemicals usually involved and added to ceramic mixtures, looking closer at their nature, actions, and of course, at the problem they can solve. I am Davide Trentini, and this is Apparently Invisible Chemistry in Ceramics. And so, even today, we start from the beginning, from the ABC, by making a list of the main ingredients of ceramic mixture that, after a long process, will be transformed in tiles. Of course, there are many components, but ceramic mixtures used for tile production, both for floor and wall, are largely made up of inorganic raw materials, such as clays, feldspar, sands, milling water, that are used in the preparatory phase, and of course chemicals. That said, let's also make a list of the different and several phases to which ceramic mixture undergo before arriving under the press. This is very important to underline how difficult is the production of ceramic mixtures marked by the right features that can promote a proper ceramic production process. And so here is the list of the best 5. First, grinding. Second, sieving. Third, stocking. Fourth, atomization. And fifth, pressing or forming. Let's now talk about the first one, the grinding phase. That is, the grinding of the inorganic raw materials that take place within specific grinding mills that may remind you the drum of the washing machine, just to give you an idea. And where clays, feldspar, and sands are crushed by using, of course, water that usually comes from the cutting and lapping department or mainly from the glazing line. We are basically talking about recovery and groundwater. During this phase, the groundwater together with the inorganic raw materials form the slurry, also called barbottina. And once the milling process has ended, the slurry is sieved, and this is the second step of our list, and stored in tanks where it's constantly under stirring in order to avoid possible gelling or sedimentation phenomena. After the storage phase, which can last for a period of time that ranges according to the needs of each producer, we proceed with the atomization step that is developed by means of spray dryers, also called atomizers. Inside the atomizer, it takes place a very complex process that we could summarize by saying that the slurry is nebulized thanks to the use of very high temperatures, able to evaporate, we may say quite violently, the water. This evaporation transforms the droplets of the slurry into very tiny hollow spheres that together form the atomized powder, ready to the pressing and forming phase. That is the last step of our list. Good. Now it's important to remember and to underline, even if we have already done it many times, that the atomized powder retains a residual humidity content that is usually about 5-7%, and that is useful to provide the granules with the proper plasticity value that ensure their deformation during the pressing or forming process. Once it has been pressed, the raw tile is in fact also called green, precisely because it still contains an amount of residual humidity, just like freshly cut wood. That said, I'm quite sure that you already and perfectly know what I've just told you in this short and easy introduction, but of course we are also talking to those who are not experts, so I'm sure you understand. Anyway, let's go on with our story by saying that, in general, the use of organic and inorganic chemical is very important. I would say necessary, in all the 5 processes we have just talked about, if you don't want to have troubles during production and if you want to produce ceramics without defects. Let's now enter into the very heart of today's episode by addressing the first category of chemicals, that is temporary binders. If on one side, as we said, the residual humidity provides the atomized powder with the proper plasticity value, it also negatively affects, on the other side, the mechanical resistance of the green tiles. And in this regards, I take the opportunity to suggest you to listen to the episode number 8 that is all about this topic. In fact, it is only after the evaporation process, and so after the elimination of the residual humidity that takes place inside the dryers, that the tile improves its mechanical strength. What does that mean? In particular, when the water leaves both the surface of the inorganic particles and the surface of the molecules of the organic binders, the inorganic molecules, and in particular those of the clays, approach and interact by means of molecular attractions, becoming more rigid. And it is exactly this kind of action that helps raw tiles to get a greater mechanical resistance. Since we are talking about mechanical resistance, if we also consider the aesthetic evolution of ceramic materials over time, and we are of course talking about the larger sizes, the slabs, and the thickness reduction, the tension and mechanical resistance of raw tiles are today 2 very important topics of the producer's agenda if they want to preserve tiles from cracks or breakage. And in this regard, R&D labs have been studying organic raw materials and chemical for ceramic mixtures, able to reduce the problem by increasing the mechanical resistance of green and dry tiles. What kind of studies are we talking about? In the past, it was very important to study the modulus of flexural strength. Today, instead, since the scenario has changed, it's more important to talk about the resistance to deformation, the resistance to impact, or to talk about the cohesion of the product more than the modulus of flexural strength. And this is quite obvious considering the different kind of mechanical tensions that take place inside these very big slabs. As a rule, to increase the mechanical strength of the dry tiles, temporary binders should be definitely used. These are chemicals that develop a binding power only until the pre-firing step, preserving the tile from possible damages. They are different from binders to cure that, once they have been added to the mixture, they definitely increase the mechanical resistance even after the firing cycle. I'll stop here because, as I told you, if you want to deepen the subject, you can go to the episode number 8, where you will find a very detailed description of the action of these wonderful chemicals. Here, I just want to tell you that temporary binders can be added, depending, of course, on the context and on the needs, during the grinding process inside the mills or directly in the slurry along the glazing line. And now, let's talk about dispersion, our second category. We have already talked about dispersion for glazes, but these actually are a different kind of chemicals that deserve a short explanation. In general, to grind a ceramic mixture without the use of proper dispersion, in addition to several other critical issues, it's almost impossible to produce a slurry with a proper rheology and a high density value. There are 2 very important features for the industrial productivity. What does that mean? Let's make a step back and let's start by talking about the process water used for grinding. That is not only water, but a very important component for a proper fluidization. What is the role of grinding water? What kind of problems do they promote, and what kind of chemicals do they need? These are the most important questions. Grinding waters are generally composed of well water and process water, generally deriving, as we already said, from the polishing and glazing department. And they must have specific features without which the entire production process may be compromised. Which are these features? In general, the composition and the quality of the water must be constant over time, so to avoid possible fluctuations in the milling parameters, that would force the companies to modify or change the production parameters. For this reason, they must be constantly controlled, especially in terms of pH and electrical conductivity. What is the electrical conductivity and what does it affect? Basically, it defines the amount of ions, that is, anions and cations, within the water. The electrical conductivity of the groundwater must be low, or even better, very low, in order to ease the fluidization process. What does that mean and why? To simplify, we can declare that a water marked by a low electrical conductivity is a water that contains a low concentrations of ions. An important amount of multivalent anions and cation, such as calcium 2+ or magnesium 2+, can negatively affect the fluidization process by reducing the thickness of the diffuse layer, I repeated, diffuse layer, on the surface of the clay limoncellas. That is, the distribution and thickness of anions and cation on the surface of the micellas. This reduction results in a general higher viscosity of the system, that is, the slurry, due to the formation of electrostatic attraction phenomena. We could say, a bit simplistically, that the solid parts of the suspension, that are the micellas, attract each other, therefore increasing the viscosity of the suspension. In other words, I try to explain it differently. A very high amount of ions, whether monovalent or multivalent, inside a slurry marked by a water low content may increase the viscosity value because the anions start to strongly interfere between the diffuse layers of clay micellas, and the only way to stop this action, and thus the problem, is to add water to the system, so to lower the ionic concentration level. On the contrary, a low quantity of ions, both monovalent or multivalent, in the grinding water allows the micellas to fluidly move one over the other, avoiding attraction phenomena and therefore an increase of viscosity. We could also say that a significant amount of ions, and so a water with a high conductivity value, is able to reduce, and I say it between quotation marks, the availability of water within the system, worsening, of course, its fluidity. If we consider that today the challenge of the ceramic industry is to increase as much as possible the density of the slurries by reducing the water content in order to increase the productivity and to decrease at the same time the energy costs required for the water evaporation process, it's clear now the reason why the low amount of water within the slurry must be marked by a low conductivity value. But let's go on. We have to admit that to avoid defects deriving from the water high conductivity by using only chemicals is very complex. However, the use during the milling process of suitable dispersants that act with a sequestrant action against bivalent and multivalent cation can for sure reduce possible defects and positively improve the processes. Dispersants products for ceramic mixture are all ionic sodium salts, and they are usually formulated to carry out all the following fluidization mechanisms. First, sequestrant action. Second, cationic exchange. And third, steric action. The ceramic mixture is an extremely heterogeneous and complex system, and this is why during a fluidization study it is important to evaluate different types of molecules in order to optimize both the cost of fluidification and the Barbottina's working density. Generally speaking, a ceramic mixture's fluidization is ideal when the rheology of the system provides, during the milling process, an average low viscosity that can reduce energy consumption and milling time. In particular, the chemicals involved must help the creation of a slurry that is not too fluid but not too overly viscous. Both these scenarios, in fact, would negatively impact on the performance of the Alsing grinding system. And just to make an example, a too high viscosity value would affect the flow of the slurry inside the pipes that lead to the spray nozzles of the atomizer. With the last suggestion, we leave now our dispersion to talk about the third category of chemicals that are sanitizing and preservatives. And we do it by saying that the trend of the electrical conductivity can also be modified or affected by possible microbiological degradation phenomena of the processed waters that always contain more or less high concentrations of organic material. What does that mean? It means that the microbiological degradation of organic molecules that involves the formation of metabolites that are the waste produced by microorganisms can sometimes increase the electrical conductivity value that in turn, as we already seen, leads to an increase in the ionic charge of the slurry, increasing the viscosity of the suspension. This is the reason why it is very important to constantly check the milling water in order to prevent any possible complication. Especially in the warmer and wetter seasons, it would be useful to check the water cycle within the production plant, identifying the most sensitive storage points and taking action with periodic sanitization process and by using a predefined dosage of proper preservatives. Even in these cases, the only possible action is the addition of water to restore mobility to the system. But of course, it is also possible to take preventive actions to avoid degradation phenomena by using specific chemicals capable of sanitizing and preserving the water. And these are chemicals capable of killing microorganisms and or avoiding their proliferation. We are talking especially about sanitizer. There are usually oxidizing chemicals when these products have a rather fast action but with short-term effects. That means that microorganisms are temporarily eliminated, but the bacteria can reappear in a short time. We speak instead of preservatives in the case of molecules that can react over time within the water, ensuring its health. To complete the list of the most important chemical category for ceramic mixture, we should talk now about those chemicals used to reduce or avoid the black core. But since this is a very hot and important topic, I inform you that we are working on a new episode entirely dedicated to this subject, and I think it's going to be ready in a few weeks. And so this long overview about ceramic bodies, ends here. I really hope I gave you a general and clear picture about the topic that, of course, you can deepen by calling or emailing us. You can find all contacts on our website, which is ceramco.it, ceramco.it. I also remind you, as usual, that the previous episodes of the podcast are available not only on the main platform, such as Spotify, Apple, or Google Podcast, but also on our app that you can download for free on Apple Store or Google Play. You can find it by typing Z and S Ceramco. Once again, Ceramco. I hope with body and soul to find you here on the next episode that is going to be ready in 2 weeks. See you soon.